Hi everyone, this is video number 17 and this is going to be the final video of the Regents Chemistry curriculum, the last video of the Regents Chemistry curriculum. And today our topic is going to be electrochemistry. By the end of this video you are going to use chemical energy to create electricity, or use electricity to create enough chemical energy to plate or clean jewelry. So here are a bunch of questions for you guys to answer. Read the following statements, determine whether they are true or false. I'm going to start this video by showing you a picture of an electrolytic cell and a picture of a voltaic cell. If you don't know the answers to these questions, that's okay. You should be able to answer them at the end of the video. Now I'm just going to show you the pictures. Pause the video if you want to take more time. If not, here's an example of a voltaic cell. This voltaic cell picture was taken directly from Lumen Learning. You can just go on Google and type voltaic cell and this picture will come up. And as we could see, in a voltaic cell, we are always going to have two pieces of metal. We call these metals electrodes. Here, example, I have the zinc and I have the copper. And we're also going to have a wire. I see where the electrons on the top left. The wire here is used to transfer electrons from the zinc metal to the copper metal in this case. We'll talk more about that in a second. We'll talk more about why the electrons are moving from the zinc metal to the copper metal. We also see that we have a light bulb in the middle here, where the yellow is. That light bulb is an indicative that it's indicating that we are generating electricity here. As long as the light is shining, we are creating electricity. We do see a solution at the bottom. We also see some kind of a porous membrane, or we call it a salt bridge, that kind of like transfers the anions and the cations in different directions. Okay, so that's pretty much what a voltaic cell looks like. Now let's take a look at an electrolytic cell. We notice that in an electrolytic cell, there is a positive and a negative, and this is right on the top here in the middle between the blue lines. We're seeing a battery. This picture was taken from Look for Chemistry. If you go on Google, type in electrolytic cells, you'll see this picture come right up. So the only difference here is that an electrolytic cell has a battery. It's powered by a battery, and it is not going to create electricity. As a matter of fact, it's going to be using electricity to create chemical energy. Okay, with that said, let's talk about the main differences between a voltaic cell and an electrolytic cell. So here's a picture just to remind you. A voltaic cell has the anode and the cathode and a nice salt bridge, and then there's an electric wire. Okay, and then there's a solution here and another solution here. This would be an electrode called the anode, and this would be an electrode called the cathode. An electrolytic cell is the same concept, but an electrolytic cell would have a battery that will power the cell, and the battery will be connected to the anode and the cathode, and there will also be a wire to transfer the electrons, and there will be a solution here as well. Some kind of an ionic solution. The main purpose of a voltaic cell is to convert chemical energy to electrical energy. So batteries is a big example. We use chemical energy to create electrical energy in batteries. For electrolytic cells, the main purpose is to convert electrical energy to chemical energy. If we have enough chemical energy, we'll be able to plate jewelry, gold, silver, or clean jewelry as well, through a process called electrolysis. So we can perform electroplating or electrolysis. Okay, spontaneity. Voltaic cells tend to be very spontaneous because they do not require any outside energy to drive a chemical reaction, while electrolytic cells are not spontaneous because they are powered by an external power source. When it comes to the compositions, in a voltaic cell, we have two metal electrodes from table J usually. One would be more active than the other. So we draw the picture again. You don't need to draw two half cells. You can just draw one half cell. So the anode would be the electrode or the metal that is more active, according to table J. And then the cathode would be the less active metal. So looking at table J, here we have the more active metals on top, the less active metals at the bottom. So obviously here, if I had zinc and copper, most commonly used in voltaic cells, zinc would be more active than copper. A very active metal is very likely to lose electrons. So in this case, if this was the anode, zinc, so this zinc is more likely going to lose its electrons and transfer its electrons to the cathode, copper, spontaneously. In this cell here, we don't really need a salt bridge to transfer the ions because we see the ions just moving freely in both directions. Okay? So since the anode is losing electrons in that direction, we're going to say that the anode is being oxidized. Because if you watched my previous video, we talked about oxidation is losing electrons at the product side. Oxidation is losing electrons at the product side. So in here, the zinc would be oxidized because it's losing electrons, because it's the more active metal. So remember an ox. So you went out at night, and on your way home, you ran into an ox and a red cat. Okay, you ran into an ox and a red cat. So what does that mean? The anode is the site of oxidation, and the cathode is the site of reduction, because electrons are flowing from the anode to the cathode. So therefore, the cathode is gaining electrons. If you remember rigor, reduction is gaining electrons at the reactant side. So the cathode is gaining electrons, and therefore the cathode is reduced. Okay, that's pretty much what this is all about. Obviously, if the anode keeps losing those electrons to the cathode, the mass of the anode will decrease and then the mass of the cathode that's gaining those electrons will eventually increase. Some of you may say electrons don't really weigh much. Well, they don't, but they could still impact the mass of the cathode, because what's happening is that this cathode is becoming more negative, and because it's becoming more negative, we're going to have more positive ions attach themselves to this cathode. These positive ions are known as cations. T reminds you that they're positive. Cations are positive. Okay. And that's how plating sometimes takes place in electrolytic cells. Electrons always flow from the more active metal, the anode, to the less active metal, the cathode. Makes sense, because the more active metal is going to more likely lose electrons. Electrons flow through a conductive wire, so there will always be some kind of a wire that will transfer the electrons. We have a lot of wires in our homes to transfer electricity. Electricity is the movement of electrons. If two half cells exist separately, then a salt bridge will be necessary to transfer the ions in both directions. So again, the cations, let's go back to that picture. So the cations will go towards the cathode, and then the anions will go towards the anode. The reason why the cations go towards the cathode is because the cathode, so here's the anode that's losing electrons. This is your anode. It's losing your electrons to the cathode. So the cathode is becoming more negative. And therefore, the cations, which are the positive ions, are going to attach themselves into this cathode. Okay. If the cell reaches equilibrium, the cell dies. And how do you know the cell reached equilibrium? That is when that salt bridge that you had starts moving electrons at the same rate to the right and to the left. So the speed at which moves electrons or cations to the right equals the speed at which moves anions to the left, and there will be absolutely no more electricity generated in this case. And all the electrons will end up making their way to the cathode, and then we have no more electrical energy being produced. If you remove the salt bridge also, you kill the cell, because the salt bridge kind of like completes the circuit. All right. For electrolytic cell, now the anode is going to be positively charged and is going to connect to the positive end of the battery. Unlike in a voltaic cell, the anode was negatively charged. So anode, it's getting really messy. So anode is negatively charged in a voltaic cell, and the cathode is positively charged in a voltaic cell. In an electrolytic cell, it's the opposite. The anode is positive, and the cathode is negative. You can recognize that. Let's go back here. By seeing, sometimes you're not going to see which one is the anode. They're not going to label them. But if you see which of the electrodes is connected to the negative side of the battery. In this case, the black electrode here is connected to the negative side of the battery, and the red electrode is connected to the positive side of the battery. So that automatically tells us that the red electrode is going to be the anode, and the black electrode is going to be the cathode. So sometimes you're going to get a question that says, which of the following is the site of oxidation? In this case, which of the following is the site of plating? Which of those will get plated? Know that the cathode is the one that gets plated. In other words, the black electrode that's connected to the negative end of the battery in this case. Okay. The cathode gets plated and increases in mass. The anode loses electrons and decreases in mass. So same situation, electrons are going to flow from the anode to the cathode, just like in voltaic cells. Electrons are always going to flow from the more active metal to the less active metal. Same thing, if two half cells exist separately, then you're going to need a salt bridge to connect them. With that said, this is pretty much it for electrochemistry. And I'm sure there's more, but this is the basic information that you need to be familiar with for the Regents. So I'm going to stop over here. I'm going to go back to the questions, pause the video, take your time, read the following statements, and determine whether they are true or false. This is it, ladies and gentlemen. I hope all these videos have helped. If you have any questions or concerns, or you need some additional tutoring, please go to www.regents360.com and email us. Thank you.